Let's start. Introduction to statistics is the first topic of business statistics. This will have introduction to statistics. Okay, it is a place. It is a domain where there will be study of data, that is numerical data, and linear algebra essentials, probability, theory of estimation and testing of hypothesis, and then we have regression models, forecasting techniques. So these are all mathematical study about machine learning and AI. Okay, as you all know, AI will use intensively mathematics. So this is the part of mathematics, one module completely, which will allow you to learn more about data, methods, and different types of mathematical models which are having capability to find the patterns in the data. Okay, so that kind of a study we can do it in the business statistics. How many of you are from business background or commerce background? Only one? Have you studied the statistics in your earlier days? Can you tell me brief about that?
Statistics is about collecting the data for one data point of how it behaves, observations for a data point. For example, sir, height of 10 students in a class.
Height of 10 students in a class. Okay.
So one is 5 foot, one is 6 feet, one is 5.1, one is 5.9, one is 5.2, one is 5.8. So average of the 10 is 5.6.
Okay.
So we can say that average of the height of the students in the class is 5.6.
Okay, so the average will be one of the insight.
Yeah, one of the insights
From the data that are collected. Okay. So in the first part of the module, we'll be looking for introduction to statistics, where we will study what is statistical learning, introduction to data and data presentations using charts and diagrams, measure of central tendency and variances. Yes, then the understanding of normal distribution with the help of example, with the help of charts or graphs. Then data pre-processing, how do you process the data, and then feature engineering, feature extraction and normalization of the data. Okay, let's go with the introduction. Okay, this first part, statistics. Let us basically understand what does that mean. It simply means that numerical data and its is field of math, that's mathematics, that generally deals with the collection of data, tabulation and interpretation of numerical data. Okay, as just now told that we will be collecting the data and tabulating it, arranging them in terms of columns, and then at the end we are going to interpret them, bringing out the meaning of the data. Okay, so interpreting the data in a meaningful way. So that will give us the edge over the data and its analysis. And mathematically, how each of the equations or formulas are consuming the data, the given data from the question, and trying to give the answer at the end. Same way, here we have the data not in a single format, there will be thousands of data points are there. So those data points will be given to an equation. So those equations are going to give us at the end the answer. All right. So for that we need to have the data being stored in a tabular column. Okay, the tabulation will be done, and then obviously we'll have a different mathematical mechanisms. Let's see that. A form of mathematical analysis that uses a different quantitative models. I hope all of you can make out the word quantitative. There are two words you can together understand: quantitative and qualitative. What does that mean, quantitative? Quantitative, where the study will be on the quantities. Okay, and when we say qualitative, we study based on the quality of data in this case. All right, the quantitative and qualitative. So here we are talking about the analysis of quantitative models. Whenever we are saying models, so it will be an equation can be called as a model, or it can be a group of equations can be called as a model here. Fine? Because
quantitative means is where we can measure the quantity.
Yes.
Qualitative means we can just feel it. For example,
we can describe it.
Yeah, we can describe. He is having a good height. We can measure it height.
Yes.
He is 5 feet. Whereas the food prepared was very tasty. We can't measure it.
Yes.
We can just feel it. That's qualitative. Whereas height is quantitative.
Quantitative. The
We can
measurement.
in terms of numbers.
Yes.
Shape, we can't put it in the numbers.
Numbers. You can just tell that. You cannot tell in terms of numbers.
Yeah, he is
Those
handsome.
quantities.
He
Yes.
is very wise.
Yes.
And food is tasty.
Yes.
Beautiful.
How much we cannot quantify.
Hardly. These are all the qualities.
Can anyone give me an example of quantitative measurement? How can we have a quantitative measurement? How long the day is? How long the duration is of the exam? Length of something that we can measure, right? How long the holiday will be? 3, 4 days, 5 days, 1 week. Length of that. How about qualitative? Yes. How the day was? The day was good.
All the adjectives in English language, they are qualitative.
Yes. So whenever we make a statement which cannot be written in terms of number, you can just say it is there. That will be a qualitative. Getting or quantitative study of numbers. Qualitative study of description or incidents in terms of non-quantitative. Alright, okay. There are many keywords that will be coming. I just want you to focus on them, and we just take out the meaning, understand the meaning, and we'll go ahead because we regularly use those keywords. Different quantitative models to produce a set of experimental data or studies of real life. Once again, one more point. It's an area of applied mathematics. What is we understand mathematics? What is applied mathematics? Question. Have you heard of this word? Applied mathematics. Practical is real life. Okay.
How we use those calculations in real time.
Okay. Using mathematics that we are studying, how can I use it? Real time or in my real life? Yes. So that will be an applied mathematics or application of mathematics. Applied mathematics in engineering, we say, right? That means in engineering, how do you use the mathematics that you have studied? All right. So that's what we are trying to say with the word. It's an area of applied mathematics. Area of applied mathematics concerned with the data collection, analysis, then interpretation. That is analyzing, finding out the meaning of it, interpretation, and presentation of it. Okay. Analysis, collection, analysis, interpretation, and presentation. I hope all these English keywords you understand. All right. Presentation in terms of I have the data and I have also found out the pattern in them, but I wanted to represent in such a way that users will immediately understand what it is. I just wanted to put a graph where the lines are there, okay, and those points are being added onto the plots, and users can immediately understand what it is. For example, currency is increasing, dollar prices is increasing, and rupee price is decreasing. So when you type that on Google, that what is the price of dollar today or rupee today against the dollar, so they will show you the representation of how it is changing, right? So that will be the one of the example that you can look for in terms of how these analysis could be done, and after analysis, how you represent it. All right. Okay. Then basic terminology that will be going to use it every time till the end of the course. Population and sampling. It is actually this collection of set of individuals or objects in real world or events whose properties are to be analyzed. Right? Example. Students in a class will be one of the population whose data or the information or their events that they are doing and any kind of data that they are collecting from the objects or population will be tabulated. Okay. So populations are the data they are collecting about those objects. So this list of objects or a list of individuals, if they are real world human beings, if they are collecting their data, then we can call them as populations. All right. If I have the population of different types of laptops details, then individual laptops grouped together, I can call it as one population. All right. A population of employees in India. Population, a group of people who work. Okay. Population of teachers. Population of trainers. Population of doctors. Population of lawyers. It's a group we are creating, and those people will be called as population. Generally, specifically targeted to collect the same specific data. That's how it is being population. And why this keyword is here and why we are learning this one is in future we'll be going to recognize how these population will help you in finding out insights about those population, more information about the population or insights about the population, or analyze the data to understand some hidden meaning in the data. So those all things you can do with the help of the population organization or collection. Collection of population samples. Data that 100, pick it, one sample. All right. So that will be a sample in the population. I hope you understand this one. Okay. Let's go back to the browser and let's look at some real-time examples. I can see there is a data being shown here. Okay, on this y-axis. Let's zoom it a little. Okay, now I can see India and US. I want $1. Okay, so I just wanted to see for the 5 years. So it is showing me on y-axis the value that has changed and the year it has changed. All right. So if you want to check the maximum, so this was the rupee value we are checking. We are checking check a dollar value. We can understand with this very clearly. I can say 5 years. Okay. These are my filters. Okay. If you have a Excel sheet also, there also you can filter it out. Here they just given a buttons where I can click it and automatically just filtering it out. Okay, I wanted to see for 5 years, and this is my rupee value: 65 rupees, 70 rupees, 75 rupees, 80 rupees. These are all my samples. They are my population of currency value each day, and they are collected for the 5 years, and they have a huge data. And that data is being plotted on the y-axis. On the x-axis, on what day and on what year the changes have happened. So those 2 points have been taken and pointed out onto the graph, 2-dimensional graph, x-y-axis, and those graph has been generated. You can see presently we are at 82.6, that's 36, and probably it will not come down. 1 month, this is 5 days, and this is 1 day, today itself, how it's fluctuating. And when you change that thing, you can see the parameters are changing. This is constant, this is changing. When you say 1 day, it is showing you the time. So based on the different instances, you require different parameters to be analyzed. The same data, no change. The parameter of x-axis is changing. Okay, this is one example. This is another example. Every year, approximately 1.5 lakh people dies on roads, Indian roads specifically, which translates on an average of on an average. They are looking for a quantity, a mathematical quantity called average, okay, on the data, and they say 1,130 accidents and 422 deaths every day. So this is one of the parameters. Every day is one of the parameters. Or 47 accidents and 18 deaths every hour. So these are my filters: every hour, every day, and on an average. All right. On an average, they are just taking these numbers, and that could be translated like this. And those kind of statistics will be available online with the different graphs. This is your line graph. Okay. COVID again. COVID's statistics. If you want to represent how India is performing and what are the amount of deaths that happened or how many people are there, corona affected people are there. So this is not a graph. It is going to be giving you the complete map, and in that it is going to add up the colors to that, and it's going to have a map, statistical map. All right. Yeah. So we're just trying to understand here that how the data is going to be represented and how this data is going to give us the information which is hidden inside the patterns of the information. You understand that? My intention of all these things is to show you why data is important and what are we talking about, because it is very important at this instance to fix up a target and aim of why we are studying it. Almost it is theory, and we have few programs in the middle. Okay, at the beginning itself we have the programs, but most of them are concepts. Basically, we need to understand why we are studying this. If, for example, you wanted to find out some pattern in the in your own life, you wanted to find out the pattern, how you improve or you are losing every time. Why you are losing every time? or somebody is winning every time. Why he is winning every time? So if you look at the pattern, what he is doing every day, what he is eating, to whom he is meeting, what books he is reading, what kind of videos he is looking at. So all those data when you collect it and when you analyze, you see the pattern. Okay, the person do like this. Okay, the person habits are the whole day habit are like this. That's why he is going this way. Okay, other students or other person's data is like this. That's why this person is doing like this. So you try to find out the links between those daily habits with their success rate. Okay, when you do that, you actually trying to relate the success with a pattern, some pattern. That means what you suggest to the other person when they ask you how does the success look like? They say these are the habits you follow because this is a successful pattern. You follow this one, you'll be successful. Okay? When you say that, you have a guarantee that this path will lead to somewhere. How you found out that? Because those people who are following this path are actually becoming good. Get it? That's how you can have many types of pattern finding technique in yourself. As you're growing, you will also see a different mechanism to find out the pattern. Like when you're a kid, you are actually trying to cry, and whenever you cry, there's a pattern. Chocolate will come. Pattern. So we teach the small kids that there is a pattern. Cry, chocolate comes. Cry, chocolate comes. Same, no change in pattern. So what is this? This is a pattern. So they will understand. Same way, we have machines who are learning the same way. Okay, if I do like this, the points will increase. Okay, next time I'll do this one. And if I do this one, the points are decreasing. Okay, I'm losing the game. Okay, I'll not do this next time. I'll only follow the things which are giving me the positive points in the game if I design like that. Get it? Same way, if kids want something from the other kid who are the same age, then they try louder than the other comparatively. Okay? Because he understands that if he doesn't cry, he'll not be getting the empathy. The other guy will win. So to win, he is trying to cry. Okay? When we grow little age, then we see that in school, students who are getting more marks are being appreciated, are being called many times in the class, the name. The teachers remember their names. Okay? Then we also start impressing teacher by answering the questions. Even at least by copying, but by asking. But we start answering those questions. We saw the pattern, right? Every day we come to school and we see the teachers come and take the specific student's name. Every day. And student also good at studying, but I want respect also. So in that angle, you learn the pattern unconsciously. We do not study that time. There's a pattern, but we unconsciously follow that pattern or trend. Get it? And those who are good at sports, for them also there is appreciation. So each of your classmates are having good at something, but you feel that I'm not good at something. All right, and you start create friends who are good, better than you, and you will also feel good. Pattern. I'm feeling good because I'm with stronger friends. All right, they're all unconsciously made decisions which make you successful or seems to have success in terms of temporarily. You just feel that you're successful. All right. So we just see that in real life. We try to find out the pattern and we try to adopt it. And whenever you do that behavior, just observe. You do not directly do that. You will collect the data. You collect the information. Unconsciously itself, you will think about it and you just wait and you just observe those data and collect the data and start observing things. Okay? So that way, you start looking for more and more data. You'll ask people, you'll ask the friends of friends, that how that guy is, how the person is, how you did that study, everything you start asking. So when you collect the data, you understand that, you believe in that data, then you start creating a friends with a similar interests. You start reading the books which are more interested to you. Get it? And when you are getting good marks, that means there is a pattern behind that again. When you just grow up, when we go to UC or diploma, we just find out that okay, the system has got changed. It is not a 1 year system; it is a semester system. Now the pattern is I have to do quickly everything, and I have to study everything and push my limits further. I have to study as quickly as possible. But it's not possible for me because I have studied 1 year. Okay. And when you do not cross the minimum mark that has been kept, the other senior who has also played around with you will come along and tell you that there is a pattern going on at the first after 10 standard, everybody will fail, no problem. You come, I also failed. So what is this? This is pattern. That people show you that there is a pattern. Your English medium you will pass. That guy is English medium, so you will pass. Your Kannada right? So instruction will be given in English, so that's why everybody will fail. The pattern is going on, so no problem. Don't take tension. Okay, both of us will be in the same hall the next time. We'll write again. All right. So there will be always you cannot observe it, but now onwards you'll try looking at these kind of patterns. You will see that whatever example I am giving to you of your real life are having information, analysis, and you trusted on the information and you are taking a decision on the information. Alright? Initially you are collecting information that what is happening. Then analyze. Okay, is it happened to me only or others are also along with me? Alright? That means you take a social proof. Social proof means I just check other results also. That's social proof. Your result came right. You know your register number. You check your result and be quiet. Why are you looking at other results? You are just checking who are along with me. So that way, because there will be a stress. Okay, I took 35.5, 35, and then somebody has taken 36, somebody has taken 40, and somebody has taken 80. And who has taken more than 80 will check. Okay, we just try to check people's result because we wanted to verify where we are. Ready? So that kind of data collection you do and you do analysis. Okay, that person have done this one, this person has done this one, this person, and I am here. What you are doing? You are actually doing analysis. You are positioning yourself in some place. You are fitting it. As simple as that. That's statistics. You did that earlier. That's statistics. You collected your students, your friends, your close friends, marks, and you compared with yourself, your marks. Statistics. And next time, when result again comes, you remember the previous data. Oh no, previously he has failed on that subject. Middle he has appeared the exam and passed it. But now I have completely cleared. But he still having one track. How do you know that? You kept that data back in the background and you are comparing your performance with your friend's performance. Alright? That's what we are trying to do in machine learning as well. We are trying to learn the pattern in the data. How it's possible? The machine can learn. Machine cannot learn. Machine is machine. If I give 0 and it just say, okay, 0 and I accept it digitally, it accepts the information, computes it. The secret behind the machine learning is mathematics. Okay, mathematics will give you the edge over understanding the data, and it will tell you what that data is all about with the help of mathematical formulas. And those formulas have been grouped, kept in one package, and we are calling them as one package as algorithm. Okay, and we have been told that you use algorithm, your data will be simplified. Okay, that's all. But basically, at the ground, there will be a data and there will be a mathematical formulas available. Together, they'll be constructing everything and making it one of the mathematical model. Alright? So when you do mathematical model, that mathematical model which is consuming the data and giving you more information, we are going to call them as machine learning models. Alright? So that's why to understand how machine learning models are being constructed with the help of consumption of data and how machine learning algorithms are actually doing those mathematical equations and what are those basic functionalities like how we are in addition, subtraction. So those kind of functionalities in statistics, how they are actually performing. What are the basic properties of mathematical equations that they're trying to solve those things and how they're trying to find out the insights about the data. And can we do that? Is the study of statistics. All right. I hope you understand now the pattern. How do I find out the pattern in the data? Getting this is very important study that we are doing here. It will be this study will be for the people who are also in MBAs. Right, sir?
Yes. So it's a very field,
Huh.
like it's in medicine also, in business, science, everywhere.
Yes.
In chemistry.
In chemistry also, yes. Wherever you go, there will be a statistics. In MBAs, they study the data with respect to the sales, with respect to the marketing, with respect to how their performance is going on. And in engineering, we try to understand how specific changes in the machines or specific changes in the software patches are actually working in terms of testing, software testing. You start analyzing how the bugs are coming with the different edits that we have done, and if you are pushing different versions of the data online, and how those changes are happening, and how those changes are affecting my performance. How many users are rejecting or uninstalling my application? I have released one version. It was 2.0. Now it's 2.1. 2.1 people are uninstalling continuously. And I can see the number are decreasing on my installation lines. And I understand that something is wrong on the application. So user behavior is also being controlled through the data itself. When you look at the Play Store, you see the number of downloads, but those are only downloads. Presently, how many applications have been installed in the phone, sir? That there will be different dashboards available in Google. All right. So that way, there is every place where you wanted to analyze and you want to understand basically what is going on. You want to understand. How do you understand? Nobody will tell you that. How do you understand? You need to collect the data, and the collected data is already there. But you need to ask the data some questions. Data cannot answer you directly. You have to put some formulas, then the data will answer your question. Like how we did earlier. We asked the question to the CSV sheets. CSV sheets are giving us the answers. So that way, we will have different fields where applications of statistics are there. So that's why we need to understand this at least to any field you go as per your interest. But in all the fields, we'll be going to utilize this kind of information or data that is studying. All right. One or the other day, all of you probably will reach to the managerial position. Definitely. If you go to the corporates, after 3 years or 4 years, you will be in the managerial area. Obviously, you will be leading a team below you, and you will become a leader of the teams. And at that time, you have to tell your top management how people are performing. Everything. Okay. At that time, definitely you will remember that statistics is playing very important role in that. All right. Okay. Now, most of us, and especially ladies, have this property of connecting multiple dots. pattern. Number eight. Okay, that was a joke. But seriously, whenever some incidents happen before 1 year, after 6 months, before 3 months, incidents will happen in your life. Okay, and you do not leave that those incidents simply. They are very costly incidents, so they you keep remember them, and those things you just keep them fresh and just join those dots, and you find out okay, this is what the reason is. This is what is happening presently. And obviously, 99% you are right because you are having the data and you are putting those situations on those data and you are trying to say this is what it is. You're not predicting the future or you're not saying something based on the data you are telling. And obviously, this yes, sir. That is how machine learning will collect the data, keep it stored, okay, and it also stores the conclusions of the data, okay, insights of the data, and try to give you more and more intelligent decisions as the data is going to increase, the number of data is going to increase. All right. So with that point, what conclusion we can come down to the discussion? The whole discussion is those who are having more information about a specific domain will be called as experts when they know how to analyze the information that they have and how do they present that information in front of others who don't know that. All right. So that's why, as a student or as a candidate who is going to give an interview, what is important to you is you need to have firstly information condition. Data must be there. That's one thing. Next, you need to know how to use that data to answer questions. All right. Do you have technical questions? It may be the soft skill questions. Information must be there. You need to know how to use that, utilize that information. Next, how do you represent the information is also very important. All right. One is storage, one is processing, and one is display. Get it? These three things, if you have it, then you're done. You will be called or designated as an intelligent person. That's how the machine learnings will have their data repositories, their algorithms, who knows how to process that data, consume that data in an algorithm, and at last they know the language knows how to represent that data in terms of graphs and charts. I hope it makes sense to all of you. Getting it? Okay. So to whom do we call intelligent person? The persons who very intelligent. To whom do we call? The person? All the information. Okay. Then?
And know how to present.
How to present the information? IQ is high. IQ is actually a multi-parametric measurement. IQ is what do you think? In what angle you see in IQ intelligence? In terms of thinking, in terms of observations, collecting data, obviously. Research means he is good at asking questions. Research is that in real time. Answering the question. Okay. Answering the question. Okay. Answering the question is the ability to crawl the data at the right time there is an ask. Okay. So we all understand now how important the information is and how important it is to analyze it and give the answer. All right. Okay. Let's go ahead. Have a look at statistics. I hope all of you have understood the meaning of statistics. The practice or science of collecting and analyzing numerical data in a large quantities, especially for the purpose of those in the representative samples. The standard error is a mathematical tool mathematical tool used in the statistics to measure variability. Do you understand this keyword? I hope all of you can see. Yeah, it is telling us something. Yeah. Yeah. Standard error is a mathematical tool used in statistics to measure variability. What does that mean, variability? Have you heard of this? Here are variables. We understand what is variable, whose values are changing. Here there is a little change word. It's not variable, it is variability. So what do you think about this? Variation? Variation, okay. Yes, measure of variation. Variation in what it is saying standard error is mathematical tool it is used for. So the variation in the data, like for example, as you're collecting some marks of students of whole Karnataka in a specific subject. So the marks are definitely going to vary. Alright? But how it is going to vary, that will be going to be measured with the help of variability property. There will be different parameters. That's not one word. That's a group of words actually. Alright. Okay, we'll come back to this later. Types of statistics. Types of statistics. We have descriptive statistics. We have inferential statistics. Descriptive statistics, it describing and summarizing a single variable is called univariate analysis. That is descriptive analysis in the category. Describing a statistical relationship between two variables is called bivariate analysis. Okay. Describing and summarizing a single variable in the descriptive statistics. I hope you understand the keywords firstly. Okay. Descriptive statistics is going to describing and summarizing a single variable, telling you what the variable is. It's called a univariate analysis. That means a single univariable analysis. Next, we have a statistical relationship, describing the statistical relationship. What does it mean? These keywords. Statistical relationship. That means it is the connection between, or you can say there is a link between statistical multiple columns or multiple values that you can consider as a variables. When you consider them multiple variables, then we can say them as two variables. I mean, between two variables, it's called bivariate analysis. So there are two variables. For example, if I say when you are riding your vehicle, two-wheeler, you will handle multivariate actually. Multivariate parameters you actually handle. What do you handle? You handle the balance, one parameter. Obviously, that's going to change, one variable. Speed is going to change every time, two parameters. Alright? And acceleration and velocity, both will change. They're all physics words, right? Acceleration, speed, and velocity. Heard of them? Okay. So all these parameters will be going to change. So these four parameters, your balance, your acceleration, velocity, and speed, all of them are your variables which will let you ride your vehicle safely. If any one variable changes, you understand that okay, this variable is changing, and I'm in control of that variable. All right. So that's how you control those variables. Based on that, we are going to have the relationship between those variables. For example, I have a variable called time, and I have a variable called speed, and I wanted to know what these variables are having relationship. Is there any relationship between time and speed? Okay. I'm just giving you the parameters which are known parameters that we understand also make relationship between. Okay, let's understand a little on that. What do you understand with respect to time? What is time? I hope all of you understand what is time. Generally, how can you tell somebody speed to distance? Speed. Is that right? Is this right? If it goes here, so this S will come here. This is right or this is right?
Sir, we go to speed into distance.
Speed into distance. This one? If I give you the speed and distance, you will give me the time. I want to reach Harvard. Tell me. You know the Harvard distance? 20 kilometers. Distance I know. Speed 50 kilometers per hour. 2 wheeler. Tell me. How much time I take to reach Harvard? So I read numbers. Okay. Speed is 50. This is my 20. This is my speed kilometer per hour and 20 kilometers. Ready? 24 minutes. Twenty-four minutes. Yes. This is not giving you the time. 24 minutes is not enough. This calculation is wrong. You are saying. Formula is wrong. Tell me. What do you want? T equal to speed. Now take the numbers are ready. Take it and tell me how much time do you consume to reach out to your Harvard? 2.5. 2.5 hours or minutes. Number you tell me and T equal to divide. Yes, sir. Very simple. You don't know how you go to Harvard. Usually, how much time you consume? Usually, maximum if traffic is there 45 minutes. Okay, and we know the probable answer 45 or 30. Right. So in that range we should get an answer. Wrong also, but in that range, not very broad. Now tell me. 40 minutes. 40 minutes. Distance is. Okay. How much? 24. 24 minutes. Sir? Okay.
So 1 by 2.5.
1 by 2.5. 1 by 2 is 0.5. How much it is in fraction? 40 minutes. 40 minutes. Increase the speed. Average again. 80 km per hour. 25 minutes. Now you check easy numbers. 25. 25. 25. Okay. 15 minutes.
Okay.
For this one? How?
20 kilometers is the distance. If I travel at 20 kilometers per hour, I reach it in 1 hour. If I travel at 40 kilometers per hour, I reach in 30 minutes. If I travel in 60 kilometers per hour, I reach in 20 minutes.
20 minutes. In 80, for 80, 10.
So if I travel in 18 km per hour, then I reach in 15 minutes per hour.
So that is 1 by 4.
Yes. That is 1 by 4. So 1 by 4 of hour is 15 minutes.
Okay. So it is 1 hour by 4. That means it is 15. 60 divided by 4. No, that's what 0.25 is in terms of hour is 15 minutes. 60 by 4. 60 minutes by 4. Okay. So you now see there is a connection between D and S. That's why you are able to arrive at a conclusion that okay, these two variables will combinedly work together and give me a time. Alright? And you also understand that all these three variables are interconnected, they are interlinked. Got it? Now if I wanted to find out, now I know the time and distance. Now I have the speed and time. I want to find the distance. Can I do that? Same thing. B equal to D to S. What will be the answer? 1 by 4. Speed is 80. Answer already. Okay. So you have connected all the variables, and you see there is a meaning of how those variables are giving the answer. For example, you have some unknown variables, and you start giving some values. So what do you try to understand? You don't understand anything at the beginning. You go on, give the values start from 1, 2, 3, 4, 5, 6, continuously start giving for one variable. For other variable also, you just keep one value constant and keep changing another value. Like I give D 1, 2, 3, 4 continuous values, and I keep my S constant 1 for example for 10 values. And again I change my S equal to 2 and again test my 1, 2, 3, 4. That's how I try to test it, whether it is working properly or not. If there is a connection between them and I have the formula being created for a specific application, to finding out distance, then I will be ready with the columns of data, two columns of data, first column and second column of data, with a different values, D, yes, D, yes. Completely, two values are ready in my columns. I'll take those values and find out the time and give it to you complete at all the times. Get it? That is how your mathematical models, are getting ready. For what? For recognizing something, for face recognition, for signature recognition, for handwritten recognition, for person recognition, for animal recognition, for fruits recognition, for leaves recognition. Get it? When we create the such formulas which are consuming the data, for example, I have the camera, it is consuming the photo. All right. When we consume the photo, photo is not a single photo; it is having the layers again. Okay, an RGB layer and its own background layer and depth layer, everything will be there. So all those layers will become input for the formula, and that formula we are going to call it as one of the okay. Now I hope you understand that model without model you cannot operate even if you have the data ready. All right. Now we understand that why the classes are having data and methods. Methods are actually models which are consuming the data created at the property space. All right. This is little advanced than the classes that we have created. This is for example, you have specific cases, like you wanted to find out a specific disease on a skin. You take a multiple photos of the skin, different people's photos of the skin, and you collect that and you keep it in a folder, and you ask your program to read those photos. And every time there are some specific patterns it is trying to find out, common patterns. All the photos is a common point. It will tell you that there is a common point in the 1000 photos. I can see there is a common point. It cannot see. It doesn't have eyes. It just have a data points. It starts looking at the data points on different places, but common points are there. Get it? Then it will give you that okay, whenever you tell in future, you don't know what kind of disease it is. You already trained your model 1000 times. 1001 time you ask by just giving a photo. Okay, tell me what disease it is. It will tell you exactly what it is. I hope you are getting it. At that time also, you need to create a models like this. This is one of the sample, small sample. This kind of a bigger equations might be there, which are consuming more information from the photos that are provided. I hope you are having a little idea of how your machines are taking advantage of mathematics and the data that you are providing and consuming the data like this and producing the outputs like this. Alright. This is one of the, we can see the values of the, we are giving the answer. We did that earlier also. From schooling, we have done that. Now we are in a machine learning class. So how it is related to the machine learning is the question. I understand this formula, we did that earlier. Whenever I wanted to improve this model, what I do is I try to take out only that kind of conclusions which have given me the success rate earlier, which have given me an positive reward in terms of recognition. When my AI check and tell me that this is for an orange, if it starts telling me the tomato, I will give a negative mark to the model. It understands that okay, I have recognized it badly, so something it is, but I don't know what it is. I tell that machine that no, it is not tomato, it is orange actually. So it adds that point in itself. So it has learned by itself that was a wrong and this is the right answer. All right. So how it is correcting itself? It is correcting its value. It's correcting its values. Then it is going to go on, learn it, and it's keep building its model. Go on, learn from the data that you are giving it. More and more data you are giving it, more and more pattern it is trying to find out. The commonalities in the data it is trying to find out. All right. Then it try to find out that okay, this apple means it looks like this. Okay, with the different photos angles, this and that. I understand. Okay, in whatever angle you show, this I know this one is this one. I understand that. And it is not going to remember your whole data. It is just going to remember the patterns in the data. That's it. For example, you have 1 TB of data. 1 TB of data you have. It doesn't remember a whole 1 TB of data. It just crawls the data and try to find out what is the pattern in that and try to keep moving that. That we call it as a machine learning models. Those models are independently so strong, wherever you put them, they start working, like recognizing. That file, we'll show that. We'll create that file in your lab. Get it? Those files will be models, and those files itself, your TensorFlow is asking you, bring your own model also, and we'll upload it. I will make it available as an API. Get it? I hope you can make out what we learned earlier in the schoolings, the formulas, and what we are trying to learn. I hope you understand that. Okay. You understand? Sorry. Okay. What if I have more than these variables? How do you find out the relationship between them? You already know the relationship, you can find it out. But if you don't know the relationship, how do you find out? Like, for example, you don't know B and you don't know S. So and it has been written like X or Y. Something has been written. You don't know that it's distance only and speed only. And some values are there. How do you find out? Hypothesis means assumption. We assume. You do in mathematics also. Whenever we don't know some value, we consider the right. We start like that because we wanted to find out something. For that, we need a supporting character. All right, we do assumptions. When we get an actual answer, we again change the assumption. Okay, we are getting wrong answer, but this is the right answer. So this is my new assumption. So my new assumption is my improvement in learning, in my equation. All right, that is what your machines are also doing. It is they are correcting themselves whenever their assumption is wrong. They change their assumption. Get it? So how we think when we get a new information which is more meaningful than the earlier information, we change our thought process, we change our mindset, and we just accept the new information. We improve it according to the new information. That's how even people improve. When new information is given to them, they start to learn that and they start to adopt that information and use that information in their daily life. Obviously, we call them as they have changed, right? Because their behavior, their thought process, their speaking skills, everything has got changed. Because the new information is making them to act like that. All right. That's how your machines are also having assumptions at the beginning when they are being tested, when the variables are unknown. All right. Now, if I tell you that I have only two variables which are changing the values, like from 20 to 30 kilometers, from 80 to 60 kilometers, the values are changing. For example, if I tell you there are 1 lakh variables which are changing, and you have to tell me in 1 lakh variables, how many variables are actually matching with the other 1 lakh variables? I mean, 1 lakh values actually. You have such 1 lakh values like I have D, I have S, I have X, Y, X, Z. So such 1 lakh variables I have. So their variation you have to find out. How do you find out the variation? By being it's not possible. Getting not possible. I am saying it may take time, but it is not possible for you to accurately identify what it is. Getting? We just have two parameters. We are able to find out the value. Even if I increase it to 10, you will still accommodate it. If I make it 100, you feel difficult, but still you do it. You take some time and it will do it. But if I tell you there are 1 lakh variables in the video which is coming up as in real time, and you have to check what it is, you have to tell the on the display what you are recognizing on the display. Then it is for the computer, it is again a task to complete. It consumes a lot of processing power to do that. Obviously. There's a lot of variables, so a lot of computations need to be done, and as well as storage has to be so intensively fast that it has to write the values, read the values completely so speed. It has to be. Getting it? That's why machine learning are becoming more intelligent than humans, because humans' capability to understand the variables and their variations in the value, and due to the variations, what is the change happening in the result? We are not able to keep focus on what changes are happening because of change of one variable. Get it? Like if you have a radio, one knob you are actually changing. Because of that, what is the output that is coming? If I give you 1,000 knobs to change it, one knob is you are changing, something is not changing. So if I change 2 knobs at a time, one thing is changing. And 3 knobs, if I change it at a time, something is also changing. So I have a lot of knobs to turn on. I have 1 lakh knobs to consider. How do you change it? Because of one change, how do you remember that you have changed it? How do you find out there is a pattern in the change? If I did first thing, how do you open the bigger lock, safe, a board safe or something? You see in the films they will be showing you, there will be safes, and they will give you. They increase the complexity of hacking or cracking the code of lockers. Why do they? Why are they difficult to open? Because they have more variables. They have increased the variables that humans can't have a variation balance. Okay, this is changing. Okay, I have to remember that this is changed. This is also changing. Okay, I have to remember this and this. This is also changing. 1, 2, 3. I have to remember that they are changing. This is 2. This is 4. This is 5. Okay, 2, 4, 5. Okay, then so many things are changing. When you change them, you need to remember them and you have to configure and try to change the knob. If I increase more number of again combinations, it will feel difficult to do that. Get it? You also have the passwords being added, the numbers added to the suitcase and most of them. The maximum number of combinations are there, the more difficulty for you to remember the numbers. Right? Because they are variables, obviously. Variables are having 10 values, 10 numbers. 0 to 9. 10 numbers I have, these are variables. What is changing? Okay, one I am changing. When I forget the password of my suitcase, what I do? Same. I keep one thing constant. Yes, one. One constant. Change it. Open it. No, not opening. 2. Open it. Not opening. You do that, right? That's testing. Same your machine model will also do that. It's trying to learn that whether it will open it or not. So what is the outcome of it? So we have 3 variables. Like if I have 3 combinations, I have 4 combinations, 4 variables I have. So I have to keep track of what number I have changed. Okay, one I have kept it. Okay, let's try with all zeros. 1, 0, 0 might be the password. Okay. So I'll make it 2 and 2, 0, 0 might be the password. I'll have a lot of combinations and permutations. Okay. So we have a lot of combinations and permutation. What is this concept? Again, mathematics. If you're doing that, it is actually mathematics. If you know permutation and combination, you would have solved it very easily. Get it? That is how probability. Probability is again different one. Probability says possibilities. How possible it is that today rain will come? How possible it is that I'll have a head or tail? Probability. I don't have definite because when I turn it, I don't know how many times it flips it and come back to my path. I don't know. So, but we cannot say it is a luck or a prediction. It's probability. 1 out of 2. One is the outcome. Out of heads or tails, 2 variables I have. So one of them will come as a. That's a probability. So all these real life experiences that you have are actually the mathematical models that we have, mathematical concepts that we have. because of which only we are able to construct the complete machine learning or artificial intelligence algorithm. Those algorithms are actually naturally having those mechanisms inside. As for your curriculum and most of the learnings, they already have the curriculums ready. I mean, the algorithms are ready. The complexities that we are just talking about with the mathematics, we are going to study it as a concept, and we need to know the concept because we are using presently the existing algorithms, which are the standard algorithms. When in the company, when you go there and try to learn to create a new algorithm, for example, small algorithms trying to do some task like this only, for example. You have been told to find out in a vehicle dashboard presently. This parameter is not there. If the company says we are developing an electric vehicle, and on a screen you have fixed up the Google Maps to give you our destination on Google Map. It's really showing the path. It is showing the speed with which you are moving. Okay. Your company says, no, you have to design an algorithm which will tell the rider in how much time he can reach the Harvard with this speed. For example, he is 60. In how much time he can reach with this speed? Present speed 60. Okay. And all these pattern of traffic in the Google Map, the vehicle can download present traffic of the Google Harvard on specific time, and then you have to tell what is the time that can reach. Okay, you are going to create a complex data fetching, and then you are going to use that data to make a decision in the vehicle. I hope you are able to understand how variables or variability in the data and the pattern of huge data as well as the algorithms which are having these kind of formulas where we're trying to find out small equation with the time. There we'll be having a bigger equations or group of equations, like one equation is giving the output, that answer is going to be taken to the next formula. So such many things can happen in one algorithm, and then we are going to arrive at a specific outcome from the algorithm. Alright, so that's why we need to understand how the data is going to behave, and how do we understand what kind of a data it is and how many variables are there in the data. Your columns are actually the variables. One column in CSV sheet, one variable, because those values are changing, continuously changing values. Variable. Obviously, one value is constant. For example, the first row value is constant, but the values are changing every time. Actually. That's why it is variation. Not the fixed number is changing from 1 to 2. No, 1, 2, 3, 4 is a change. Getting it? As we are dealing with the numbers are same only, same constant numbers only, but the numbers are changing in the list. Got it? Okay. I hope you have also studied or heard of the problems of trains. Heard of trains problem? Okay. Can anybody tell me what is the problem at least in finding out the time of the train? How it is different from here? Finding out when does the train arrive? The train is at somewhere and it arrives. When do they intersect at each other? Okay, that will be one thing. And platform, yes, platform's length, platform's width is this much, and at what time it crosses, at what time the complete train can process. That means the length of the train will also be considered, that when it will compared with the platform's length actually. So those problems you have to know and understand to give an interview in the companies. They will check again, same thing. How much data you have, how good you can use that data, and how good you represent the data. Alright, that's what it is. Nothing more than that. You know how problem can be read, and how that things should be, how you can perceive the data that has been given in the product statement, how you can find out the distance between two trains when they are coming opposite, when they are going parallel. Okay. Heard of theory of relativity? Theory of relativity. Relativity means not relatives. Those relatives are not parallel. The relatives are opposite. Theory of relativity. Heard of it? Heard of Einstein? Yes. Who was that? E equal to mc square.
So Apple is almost
He is Newton. Right? Okay. There's a question for all of you. When you are moving in the train with the same speed, what will be your speed? Speed 0? Can you run in the train, inside the train?
If the train is 50 km, we can run it. If train is moving at 60 km per hour, and in the train if I am running at 20 km per hour, so my speed related to the person standing outside the train will be 60 plus 20, 80 km per hour.
Yes. Get it? Obviously, when the train reaches, you will also reach. But in terms of relativity, there's a question. There's a train moving at 100 km per hour, and you are also running inside the train. From last to first, you took a general bogie, but you have a reservation, so you are running. So there is a relative speed that will be calculated when you are coming opposite. The speed will be added. Speed will be added. Speed will be added. When you are going in parallel, if you want to calculate the speed, it will be negative. Alright? Okay. So if the train is at this point A, and the distance of 5 km platform B, and the train has to cross this thing. The train has to cross this thing, and the train's length is 10 km, for example. It's very much higher. I say 2 kilometers. I make it 5 km. Okay. So how do we make it? The question is, when does this train will cross this speed?
So it's more than 5 km per hour speed.
This is 5. No, this is the distance of this one, the length of that. We'll make it 500 meters. 400 meters. The speed will be, the platform speed will be around 80. This is static. This is moving. How do you calculate? How do you see? Formula you give it, everything you give it. Just put the common sense and just tell it generally. I don't need the actual. Whenever such kind of things will come in front of you, you just need to see what are my variables and what are my constants. Now identify what are your constants and what are your variables, which is changing continuously. One or two or three variables are actually changing continuously. What is changing? Speed is changing. Correct. Next. Don't think in terms of technology. Distance is same.
No, sir. When they will come to near the patient, sir, distance will be reduced.
Okay, this system will be reducing.
Yes, sir.
Okay, so that's one thing. Next, velocity of that. Okay, velocity is one. Next, time important. Time is also varying. You just need to see how the train is using all these parameters. It is using time and it is using speed to cover you told T, you told yes. This is how we need to take the variables, connect them to each other. Alright? You are telling there will be a time and there will be a speed and it is trying to cover the distance. Right? I hope you are getting that angle of looking at the data that will be given to you. Alright? This is what the angle that you are looking at the information has to be changed like this. Now onwards, any domain, any places, any information given to you like this has to be focused on. Okay, now what is changing? What is fixed? Or this is distance fixed. Okay, what is changing? This is changing. Okay. Now, if I change time, what will happen? Okay, if I give more time for a train to reach, it takes less speed. Reduce the speed, it takes more time. If I increase the speed, how will the time increase? Decrease obviously. That's so. Try having this problem statements every day. You'll have practice of this thing. Yes, run rate is also one. Run rate is run rate and present run rate. Okay. History of the player. Yes. This is important presently because we are going to have these kind of problems in aptitude tests in interviews. You need to know those variables and how they are changing. Immediately, dynamically, interviewer takes your sheet where you answered those objective answers. And they ask you, why can't this be answered? Because you wrote A is the answer. Why the B answer which is showing this number is not an answer? If you randomly put it, even though it's the right answer, you randomly put something, you may not know why you put that, then you have a difficult time. And that time you have to adopt your mind. Your mind should be adaptive, I'm saying. You know that problem or not, what should I do? That's up to you. You should have an angle of looking at it. You look at the numbers as parameters which are changing, which are not changing, and what is the relationship between them. This is what mindset I want you to have it as you are going into the chapter of Keonicsx statistics. That is business statistics. And we talk about here most of them as the statistics related to the business logic only. Alright? We'll definitely take a lot of examples, but this is the business statistics. Alright?
So these kind of problems are asked in interviews.
For sure.
AI.
For sure. Obviously, you can design AI for this one. As we just told, S equal to D by T is one of the model. It's consuming the data, giving you the answer every time. It is improving its ability to give you the answer every time by consuming the data more and more. That's what the machine learning is. I just minimized it and show you the how it looks inside machine learning. Yes, any questions? Yeah. Whatever I'm explaining, they are each sections of your module 3. I need to understand it very clearly. Let's go ahead. Descriptive statistics. Describing and summarizing a single variable, univariate, relationship between two variables, bivariate, describing the statistical relationship. So here also there are variables which are changing, but how many will give you the different. Okay, single variable, univariate, two variables are we are checking, bivariate. You know, multiple variables more than two, then call it as multivariate analysis. There are two types of descriptive statistics again. Measure of central tendency and measure of variability. Understand both the keywords. Measure of central tendency. Central tendency. You understand what is the central? Okay, it is the middle of the data points that you are considering, or the column that you are considering. For example, you consider one column of the Excel sheet, and we are talking about only the middle part of the Excel sheet column. Not at the beginning or at the end data. Ignore that, only mid part of it.
Or it can be gravity of the data set.
Yes,
Where the data
balance is being provided. Exactly. Central tendency. Tendency means it is the behavior of the data which is at the middle. All right, and it can also be the pattern that is there in the center of the data. And this will be the variability, the measure of variability, how the data is varying, not at the middle, not at the end, not at the beginning, all the place. But the variation we want to check it. We don't want to focus on any one of the part. Just we want to see changes happening or not. That will be two types of descriptive statistics. Statistical learning, measure of central tendency. Let's go and see only one part of this presently. The measure of central tendency is a single value that attempts to describe the whole set of data. We say there are three main features of central tendency. That is mean. We can find out at the if you give me the list of numbers, I try to find out the mean of that, and we can find out the median of that, and we can find out the mode of it. All right. I hope you understand these keywords. Number of entries, there will be even number of entries. If there are odd number of entries like 5 entries, 5 numbers I have it. If I ask what is the middle number that I can pick it, you will pick the third number. Alright, 1, 2 from the top, from the bottom it will be 1, 2, and we will be having a middle number as third number from the top. You pick that. Okay. When you have even number, how do you pick the middle number? To pick 2, you have 4 numbers. Which is the middle number if I ask you? Okay, those 2 numbers that you have it will be the median low and median high. Alright, so that way we'll study that. We'll go ahead. We have some diagram here. Descriptive statistics uses data that provides a population either through a numerical calculation or graph or table. So what are we saying? We are saying this descriptive statistic uses data in the tables that provides a description of population. Population is equal to the data of any individual or event or any object. Okay. So here the object is car. So that's data we are going to collect it and we can tabulate it. So that data we are going to use it as a numerical calculation and we show it in terms of graph or table. It provides a graphical summary of data. It's simply used for summarizing the objects. Summarizing the object means it is just to address the variables or the fields of the data. There are two categories in this following. We have a measure of central tendency and the mean. First one, we have a mean. You can see the formula. Before that, you just look at the data we have. We have a cars. These are my objects, and these are population of objects. Different cars. I told you earlier, collection of individuals, property of individual objects in real time will be population. So in cars we have Swift, Verna, and Centro will be three entries, and they have the variables. They have mileage and cylinder. Do you see how where is the variant here? Is 21.3 mileage. We have 3, 20.8, 2, 19, and 5. 5 cylinders. This is the number of cylinders. I hope you understand these names of the heading. Understand this? Mean m equal to lowercase m equal to sum of all the terms divided by total number of terms. What do you understand with this formula? Average of all the entries. Okay. So sum of all the terms that you are considering to add will be on top, and in the denominator will have total number of terms, total number of the items, plus count of elements. So there are 3 elements, so divided by 3, there are 3 mileages available. So I am trying to find out the average mileage of all that. That's how it is going to help you in finding out the mean. So what we say mean, measure of central tendency. It is also known as summary statistics. Summary statistics. It explains the statistics that is used to represent a central or center point or particular value of a data set or a sample data. We say there are 3 common features as we told. First one is mean. We did that here. Example, import statistics. And then we have list being created 1, 2, 3, 3 2 times 3, 2, 4, 3 times, and 1. Using mean as a function to calculate average of list, we will have we'll try to find out the average of it. Can you calculate the average of it and tell me? 1 plus 2 plus 3 plus 3 plus 2 plus 2, 15, 16, 16 by 16 by 8.
16 by 8.
16 by 8, how much? 2. So the answer will be, alright? Okay. Yeah, so that's how you can find out the mean of it. I mean the average or mean, whatever you call it. Both interchangeably you can use it. Mean is the sum of observations divided by the total number of observations or the total number of counts of the observations. It is also defined as average, which is a sum divided by count. Okay, both we are saying same definition in different words. Sum of observations plus data divided by total number of observations. How many quantities? Okay, same thing here also. It also defined as average, which is sum divided by count. Obviously, you get a numerator as sum. You divide by number of count. That's what it is. The mean function returns here the average of data passed as its arguments, and then if the argument is passed is list is empty, the statistics error will come. If not, we give you the average of that. All right, we can use this one. Let's take a next file, that is module read or IP by NB. Okay, I need to import statistics. Then I need to have a list of data. Okay, list equal to okay. Let's try to find out what is the formula we need to use. What is the function? Name, mean, is the short. Okay, I don't want to use the complete spelling. Statistics. Can I shorten it?
Yes.
Statistics.
Stat. Will give error. Will give error to me. No, stat is English word. We can spell it, but that name I want to shorten it and I want to use it. Import statistics as ST can be the short form of statistics. You can customize. You can also write your name here. You write your name here or initial of your name. That will be one of the keywords that you can use it here without any. Got it? ST dot. So it explains something to you. Return sample arithmetic mean of data. It is explaining you 1, 2, 3, 4, 4. The answer is 2.8. Is that right? This 14.
14.5, yes.
2.8. Same way it is also explaining with respect to fractions. F of mean of there is a list and there is a tuples. F of 3, 7, 1, 28. You can find out the decimals also. For decimal D, you can add it. Yes, that's how it is. Let's go ahead with the integer numbers. We wanted to provide the list as input, and is asking us, and asking the list. You have to provide a list. In that only you type it, or separately you type it and give the name. It's up to you. Getting this whole list. If you want to write it inside this one, that is also possible. Here, or you can type it separately and give the name inside that. Both options you have. All right. Now I need to print this one. Okay, there is an IP by name. Let's try this. So we have 2.57. We have 9 numbers added. So what will be the sum of this? 45 by 9. So it's exactly 5. So this is your mean. So there are many functions available. You can see there will be F mean, median, ground, mod. All of them are there. You can one by one we will be going to use them. Typing heavy. You got it? No problem. You just please answer. You can understand that. Okay. If the numbers are not there, it says we will be going to generate the error. Let's see the error also. It says mean requires at least one data point, so it cannot use that thing. What is the error name? Statistics error, and it was telling us inside this. It was telling us that you get a statistic error if the data is empty. All right, let's go ahead. We have a median. I hope you know median. It's a measure of central tendency of value of sample set. In these data set, it is ordered from lowest to highest value, and then it finds the exact middle of the complete list that you are providing as a population. So we have the same example as cars, that is cars, mileage, and cylinder. Here we have taken ordering the set from lowest to highest. Ordering the set from lowest to highest: 15, I-20, 19, 10 to 20.8, and 21.3. And here we have the median as 19 in terms of the values, and plus 20.8 among 4 values. 4 values, the middle is not there. 5 numbers, if it would have been there, then the third number would have been the middle number. So now you don't have the middle number, you have to pick 2 numbers. These 2 numbers you have to pick it as the middle numbers. Okay? Those numbers will be added, and then you are trying to find out the median of it. That is divided by 2, and that is your 23.5 is your median. I hope you understand how it is doing it. Got it? That is your median. You want to find out the median. What is the median? 25. Yes. How 25? 20 method?
You add one more value. You add one more value in the list.
15. How? Median is the middle number. On the left side or right side, it has to become the middle number. Yes. So from here, I say 1, 2. This is the third number. From here, 1, 2. This is the third number. So this is my middle number. So that's been printed. If I only have the even numbers, count even numbers, I have 4 numbers. From here, if I come down, I have 1 and 2, and there is no middle number. From here also, from 1 and 2, there are no middle numbers. So these 2 numbers will be taken. 20 plus 30, 50 divided by 50 divided by 2, 20. That's math. Alright. That's the example given here. And how about mod? It is a value most frequently arrived in samples. It says repeated times. Yes. It is the value most frequently arrived in sample set. The value repeats or repeated most of the time in the central set is actually the mod. So what will the value repeated? And how many times repeated? 4 is repeated 5 times. Okay. So it is a value most frequently arrived. Okay, most frequently arrived. So that will be taken up. Okay, let's see the actual effect of it in the code. I change the data. What will be the, what should I write here? If I remove all the 4s, if I remove 1 4, here's 1. Yes. Two things you need to observe. Let's change the numbers. Just observe this. How many 1s and how many 4s? 2 times 4, 2 times 1. Same count. 2 2. So first occurrence is 4. 4 is 2 times. So that will be printed as that will be written as one of the values. That's what it says in here. Returns the most common data point from the discrete or normal data. It says mod assumes that discrete data returns a single value. As we can see 1 as a single value. Can you see? This is the standard treatment of the mod as commonly taught like this. As we have 1 1 2 3 4 times and 1 times 4, and here it gives 3 as a number. So 4 times it has repeated. This also works with the normal, non-numerical data like red, blue, all of them. They are words. Here also it is repeated repeatedly 4 times is there. Red 1, 2, 3, 4 times are there. So that's how it is going to repeat it. There are multiple mods with the same frequency. Frequency means number of times arrival of the data. Returns the first one encountered. We are in the same case presently. If you have same number of occurrences of the number, then the first one will be returned as a outcome. If there are multiple mods with the same frequency, return the first one. Got it? That's how the output we are getting it. We have 4 4 1 1 2 times. Since the 4 4 is also 2 times, 1 1 is also 2 times. Then having 4 is being given. So if I increase the 1, now 4 is 2 times, but 1 is 3 times. So now I am definitely expecting 1 itself as an answer. Got it? Okay. That's what the mod is all about. The next is measure of variability, that is range, variance, and dispersion. Measure of variability is also known as a measure of dispersion. I hope you understand what is the meaning of dispersion. Dispersion? Disperse. Okay. Time is for dispersion. Okay. Giving signal. Okay. Measure of variability is known as a measure of dispersion, that is spread and used to describe variability. Okay. In the sample or a population, the column of data, how the data is being spread across, that is going to give you that. That's what variability is going to measure. All the functionalities of this one, variability, is going to be pointing out the same behavior for the data. Those things are range. It gives a measure of how spread apart values in sample set or the data set is, and that we can find out with the help of range equal to maximum value minus minimum value. That will give you the range of values available in the complete data. For example, in this one, I have the data like 4, 6, 4, 4, 6, 8, something. But I have to find out what is the maximum value in that, and what is the minimum value in that. What is the maximum value in that? 9. Minimum value is 1. So 9 minus 1, 8. 8 will be the range of range we have it, as it is going to give us the how spread apart the values in sample are. Okay. It's a measure of how spread it is. Variance, it simply describes how much a random variable differs from expected value, and it is also computed as a square of deviation. I hope all of you understand the standard deviation formulas, the summations used to write in the mathematics grades. Okay, so that is the deviation keyword. How much random variable differs? You understand this word. We understand the variable, a variable whose values is going to change during execution time. That definition we understand. Random variable is nothing but a variable which is holding some random value, which is not definite. Differs from expected value. So I hope you understand what is this one. Expected value means you know the value. Random value means you don't know the value. Some value I don't know what is it. So it describes how much random variable differs. That means difference is there from expected value to a randomly generated value. What is the difference? Randomly generated value 10. Actually, I should get 8. So difference is 2. Get it? That's what. That means it is just predicting the value, how nearby it is coming, and it is also computed as a square of deviation at the end. In these formulas, it represents total data points. That is, x bar represent the mean value. Okay, we don't have the formula. We have it in the Google. Represent mean of the data points, and xi represent the individual data points. Variation you can see. Okay, we can see later. Dispersion. It is a measure of dispersion of set of data from its mean. What does that mean? It is saying from its mean, it is going to spread across. Across means what? Two sides. And in the middle of the data, Excel sheets column, and on the top there is the one side. On the bottom there will be another side. So both the side, how the data is getting spread, that is going to measure. That is being measured with respect to dispersion. And there will be variance, dispersion, and range. Three things are there. And we have inferential statistics. That is next one. Okay. I hope all of you have understood till now. Any questions? We have studied so far measure of variability, which is going to measure of how numbers in a column are going to be varying in terms of numeric values in a column, and that we are trying to find out with the help of three functionalities, that is range, variance, and then dispersion. And we studied how our descriptive statistics is going to help us in understanding the descriptive statistics with the help of mean. We understood okay, we first saw the mean, right? Okay, mean we saw with the help of this one, and we saw in one of the example, we saw median, which is describing about the data, and then we are going to say the mode. Three things we saw, right? Mean, median, and mode. So these things we saw, and we just have covered one part of the hierarchy. So we spoke about types of statistics, and when we came to descriptive statistics, which is going to explain about the data, we have two things: measure of central tendency, only talking about the mean, median, or okay, and another one, measure of variability, how data is varying in terms of numeric values. That we are going to study in the next class with the help of range, variance, and dispersion. Once we finish practically understanding the meaning of this one, we will directly go to inferential statistics. All right. Yeah. So we are here right now. Okay. We are not spoke about data. We spoke about data. We not spoke about the data presentations. Okay. With about that. All right, we'll stop here today.